brain. But anyway, the whole point is this, that these two angles are vertical, they are equal, so that's what you do in order to solve for x. So basically you can see we're doing some geometry, but algebra within the geometry questions. So again, whatever I do to one side, do to the other. To solve 2x minus 4 equals 110, add 4 to both sides. To get rid of that times 2, you divide both sides by 2, and that's what x equals. Then when I plug in 57, you darn well better get 110 for that, because 110 equals 110. All right, didn't want to bore you too much on this, but what should these two equal? Well, those added together using what's called the angle addition postulate should add up to 90 degrees. So be aware of that symbolism. And then I won't solve because we're going to do some solving later. What kind of angles are these called? Vertical. Good answer if you answered. And vertical angles are equal. So these are the things that you need to know, just kind of shoving you the information as we go. Now, unfortunately, we don't have a book, okay? So I'm probably going to show this on a separate video, and then when I send the email, I'm going to say everyone better watch this video as far as how to solve a two-variable, two-equation system. That's probably the most difficult algebra we're going to do. I'm only worried about if you're going to teach 8th grade, 9th grade, and maybe even 7th grade, even though at that point I think it's specialized like to subject matter. You might end up teaching something that bad. It would be the worst math that we do, and we're going to go over it quite a bit before I test you on it. So just wait for that video. All right. Now, I said there was no proofs in this, okay, but basically this is as close as you're going to get. In section 1.5, which you don't have a book, which I don't know how I'm going to go about doing this, there are properties of solving equations. So I think you could kind of go along with this and emulate this question as I go through it and I explain it. And then I'll have something maybe almost exactly like it on the test. So that there we go again. I love it. Excuse me. I love that you get to hear my coughs too during this. But anyway. All right, so first things first. I've said this thing 3 times now. And this is the 4th. How come we could say this? Now look at the names here. Angle ACB, that's angle A to C to B, C being the vertex, added to angle B to C to D, should equal angle A to C to D. All right, and that makes sense. That is the exact angle addition postulate. Okay, that's what I mentioned before. This angle plus this angle should equal the whole angle that it is that helps make it up. We talked about that with 180 and 90 questions right here. I use that term. Okay, angle addition postulate. This plus this should equal the whole. This plus this should equal the whole. And this whole in this case is 90 degrees. This whole in this case is 180. Hopefully not over explaining it, but just worried about the terminology. So at least know that that's what that is called. We won't do a lot of naming of postulates and having to memorize them, but this might be one of them. Then the next thing is, what you need to understand is, and even in those previous questions, what's this silly little thing in here? Well, it's actually should have a degree mark on it because it's saying this is the unknown degree measure. All right, and this is what we like to do, which is made up by somebody. And this is the unknown degree measure for that angle. And then in the question given, they say AC to D, so that is this whole angle measure equals 85 degrees. So by the angle addition postulate, this angle plus this angle should equal this angle. I should be able to substitute the name of the angle with its algebraic or actual measure identified. So this is the substitution property. So again, what do you have to do over here? Give reasons that make sense. How did this happen? And then how did it turn into this? And substitution is you replace something with something else. You know, back in Algebra 1 days, x equaled 2, and then you had this expression, x squared plus 4x minus 5. Substitute. Okay, so what does that mean? Wherever there's an x, you do what? You put a 2 in its place. Okay, so I know I'm off to the side here and explaining what substitution means, but that's what's actually happening here. You'd be responsible for filling in the reasoning behind how I went from here to here. All right, now what happens next? I should have this. I'm going to pause the video for a second. Okay, I hid that, so I'm all cryptic now, what the answers are. Okay, so now what happened from here to here? 85 didn't change, but somehow 5x appears here. 5x came from adding 4x plus 1x, and this is kind of going through how do you solve an equation. So 4x plus 1x equals 5x. Negative 1 plus 6, because they're on the same side of the equal sign, have to be added to become plus 5. This is actually just called combining like terms, or simplifying the left side of the equation. Oh, there's my bell at school. Okay, so I'll probably have to, and there's that thing again. This is awesome. All right, so this is called simplifying or combining like terms. So this is, I will use this term a lot. As a matter of fact, since the bell rang, I'm going to have to end this video at the end of this question and then start a second video for the next 2 pages. All right, but this is a term I'm going to use a lot even in the next video as well. Combining like terms is what happens here. Now it's when we do our undo operation. So what happens from here to here? Well, all of a sudden this 85 turned into an 80, and all of a sudden this plus 5 is gone. So what did you do to both sides? You subtracted 5, which is called the subtraction property of equations. Whatever I do to one side, I do to the other. So if I subtract 5 from one side, I can subtract 5 from another. All right? So that's why that's called the subtraction property. And then what happens here? All of a sudden 5 is gone, and all of a sudden 80 is 16. Well, that's because you divided both sides by 5. That's how you solve equations. Write the property. This is the division property of equality. If I divide one side by 5, I divide the other side by 5, and I still have a balance. All right? And then what's the last thing? Well, all of a sudden something happened. I had to find the measure of BCD. How do I find the measure of BC to D? BCD is equal to x plus 6. There's that cough again. It sneaks up on me all the time. All right, and then so what does that mean BCD is? Well, you found 16 for x, so we're going to do what with 16? What's that called in order to get 16 plus 16, which is 22? Starts with an S. You can see the little beginning of the S there. You're right, it's substitution. So that's how you get the actual angle measure. All right, so what just happened here? You're going to have to describe in words what happened over here through properties of equations, in solving equations. This one a little bit, tough. Get used to the word substitution. Most of the rest represent what you do in an undo operation scenario with equations. All right, and then we end with that. All right, so I'm going to continue with a new video because I have to interrupt this for the next 2 pages of notes, I believe. And then that'll be that. Okay, bye.